This is the USS Gerald R. Ford. More than a ship, it is a quantum leap in the history of naval warfare. Why is this nuclear colossus replacing the legendary Nimitz-class? How does its complex system of decks and layers manage to accommodate the air force of an entire nation in the middle of the ocean? And the most crucial question, why did the US Navy replace the reliable steam catapults with such an expensive electromagnetic rail system, capable of launching 4 aircraft in less than 60 seconds? In an era dominated by drone warfare and hypersonic missiles, can this $13 billion giant truly defend itself? The answers, and much more, are in the following video. The USS Gerald R. Ford, built at a cost of $13 billion, is the epitome of modern naval engineering. It is not just an aircraft carrier. It is a floating city with unprecedented power projection capability. To contextualize, the Ford is the largest warship ever built in terms of displacement and flight deck size. Although the Nimitz-class carrier looks similar in silhouette, the Ford's deck is significantly larger and, most importantly, more efficient in its organization. To understand its scale, the Ford has about 25 decks or layers, extending from the keel, the ship's backbone, to the top of the superstructure, compared to the 18 decks of the Nimitz-class. This difference in design and internal volume gives the Ford a crucial operational advantage. It can carry up to 90 aircraft, about 30 more than the typical operational capacity of the Nimitz. This is largely due to its larger, more open hangar bay, with optimized logistical corridors and the wider, cleaner flight deck. The majority of the aircraft are stored in the hangar, a cavernous space directly below the flight deck. The hangar extends for about 2/3 of the ship's length, providing vital space for aircraft storage, maintenance, and preparation. The flight deck itself covers an area of approximately 4.5 to 5 acres, the equivalent of about 4 American football fields. This immense area allows the carrier to accommodate and operate up to 90 jets and helicopters at its maximum capacity, a true moving air arsenal. The Ford optimizes aircraft movement with only 3 large elevators, in contrast to the 4 smaller elevators of the Nimitz. This reduction is possible thanks to a smarter design and a smaller island, superstructure, moved 43 meters further aft and 4 meters further back, freeing up more usable space on the flight deck for more efficient aircraft handling and operations. This strategic change reduces congestion and increases the speed of aircraft movement from the hangar to the flight deck. What truly sets the Ford apart and makes it a 21st century war platform is its state-of-the-art nuclear propulsion. 2 advanced nuclear reactors, the A1B advanced reactor, provide virtually unlimited power. These reactors are the ship's pulsating heart, generating a colossal amount of heat that boils water, creating high-pressure steam. This steam, in turn, drives giant turbines that are connected to 8 General Electric generators. This power generation capacity is so massive that it could easily power a city of 100,000 inhabitants, providing 3 times more electrical power than the Nimitz-class. Nuclear propulsion offers the Ford's greatest tactical advantage: unlimited autonomy. The ship can operate at high speed, above 30 knots or 56 km/h, for indefinite periods without the need for refueling. This is crucial for evasive maneuvers, for creating the apparent wind necessary for aircraft launches, and for sustaining global operations without dependence on a vulnerable fuel logistics chain. The operation of the A1B reactor is a masterpiece of engineering. It uses enriched uranium fuel elements, and the fission process is rigorously controlled by control rods that absorb excess neutrons. The heat generated is transferred to a pressurized water circuit, primary circuit, which in turn heats the water of the secondary circuit in steam generators. The resulting steam is what moves the turbines and, through massive gearboxes, the 4 propeller shafts that propel the ship. The used steam is then condensed back into water and the cycle repeats, ensuring that the Ford can sail for more than 20 years without the need for nuclear fuel replenishment, a significant improvement over the Nimitz-class's 13 years. The Ford's greatest technological advance is the replacement of steam catapults with the Electromagnetic Aircraft Launch System, EMALS. This is the key to its operational superiority. The EMALS uses the electrical energy generated by the A1B reactors, temporarily stored in capacitors. At the moment of launch, this energy is converted into high-frequency alternating current, powering a linear synchronous motor embedded in the track. The aircraft is connected to an electromagnetic shuttle that is accelerated by a moving magnetic field, like a maglev train. Smoother and precise acceleration. Emails applies a customized launch force for each aircraft, reducing structural stress and wear by up to 30% compared to steam catapults. This prolongs the aircraft's lifespan and reduces maintenance costs, a critical factor for the F-35C fleet. Unmatched versatility. It allows the launch of a much wider range of aircraft, from heavy fighters like the F-35C to lighter unmanned aerial vehicles, UAVs, with precision control. This capability is vital for the integration of future combat drones, such as the MQ-25 Stingray, which will be the first aerial refueling drone to operate from an aircraft carrier. Increased sortie rate. The Ford can launch up to 25% more aircraft per day than the Nimitz-class, which is a decisive force multiplier in combat. The 4 emails catapults can launch an aircraft every 60 seconds, allowing for an unprecedented sortie rate. The Ford also features the Advanced Arresting Gear, AAG, the Advanced Aircraft Recovery System. The AAG replaces complex hydraulic systems with an electromagnetic system and water turbines under the deck. This allows for a smoother and more precise stop, reducing stress on the aircraft and allowing the Ford to recover more aircraft faster, increasing the sortie generation rate. The digital control of the AAG allows for real-time adjustments, ensuring landing safety for aircraft of different weights and speeds, a crucial advance for the operation of unmanned aircraft. It is impossible to talk about the USS Ford without mentioning the challenges that marked its development. The integration of so many cutting-edge technologies such as emails, AAG, and the new weapons elevators resulted in delays and a significant increase in cost. The Ford became a symbol of the dilemma between the need to innovate and the complexity of introducing entirely new systems on a critical defense platform. Emails, in particular, faced initial reliability problems, which were widely publicized. Initial reports pointed to an unacceptable failure rate, generating criticism about the decision to adopt unproven technology. However, the U.S. Navy heavily invested in correcting these problems, and recent operational tests have demonstrated that the system has met and exceeded reliability goals. The lesson learned is that the transition from a 60-year-old technology, steam catapults, to a high-power electromagnetic system is a complex process, but necessary for the future of naval aviation. Overcoming these challenges not only validated the technology, but also demonstrated the Navy's ability to solve complex problems in real time. In addition to emails and AAG, the Ford introduced the Advanced Weapons Elevators, AWs, which use electromagnetic motors to move munitions from the magazines to the flight deck. These elevators were perhaps the biggest point of contention and delay. Designed to be faster and safer than traditional hydraulic elevators, the AWEs faced persistent reliability and certification issues. For a long period, only 2 of the 11 elevators were fully operational, limiting the ship's ability to quickly rearm its aircraft in a combat scenario. Overcoming these problems, which required millions of dollars and years of work, was a crucial milestone that allowed the Ford to achieve operational readiness. The complexity of integrating electromagnetic systems in a naval environment, where corrosion and electromagnetic interference are constant, underscores the inherent risk of radical innovation. The Ford's technology is a game changer. Did you know that emails and AAG are essential for integrating future combat drones? Leave a comment below with the word Ford Tech, and we will make an in-depth video on how these systems integrate with UAVs. Also, if you are interested in naval combat simulation, check the link in the description for our sponsor and receive an exclusive welcome package. This giant is not unprotected. The Ford incorporates state-of-the-art point defense systems designed to neutralize threats in an environment of drone warfare and anti-ship missiles. The defense is organized in layers. Area Defense, CSG. The ID Ford is protected by its Carrier Strike Group, CSG, which includes destroyers and cruisers with long-range missiles. 2. Point Defense. Missiles. RIM 162. Evolved Sea Sparrow Missile, ESSM. Surface-to-air missiles for point defense, with the capacity to engage targets up to 50 km away. The Ford can fire these missiles in rapid succession against multiple threats. RIM-116 Rolling Airframe Missile, RAM, short-range point defense missiles, designed to shoot down cruise missiles and aircraft. Point defense, guns. Phalanx CIWS, close-in weapon system, the Ford's last hope. If a missile manages to get through, the Phalanx goes into action. It is a 20mm Gatling gun, capable of firing 4,500 rounds per minute, guided by radar, creating a wall of lead to disintegrate approaching threats. The Ford uses a dual-band AN/SPY-3 active electronically scanned array (AESA) radar system, which processes a massive amount of information instantly. This radar is the ship's electronic brain, capable of tracking hundreds of targets simultaneously, from low-altitude cruise missiles to fast attack drones. The fusion of sensor data allows the system to quickly identify small and fast threats, such as drones, coordinate multiple weapon systems and engage them with precision, requiring much less manual control than older carriers. The Combat Direction Center, CDC of the Ford, is the nerve center, where situational awareness is maintained and engagement decisions are made in seconds. The Ford's air wing is its primary weapon, composed of about 75 to 90 aircraft. The typical composition includes strike fighters, F/A-18E/F Super Hornet, and crucially, the F-35C Lightning II, the naval version of the fifth-generation stealth fighter. The capacity to launch the F-35C with a full fuel and weapons load is a key differentiator of emails. Airborne Early Warning, AEW aircraft. The E-2D Advanced Hawkeye, with its giant disc radar, acts as the eye in the sky of the strike group, providing long-range surveillance and air traffic control. Electronic warfare. The EA-18G Growler, specialized in electronic warfare, capable of jamming enemy radars and communications, paving the way for strike aircraft. Logistics and rescue. MH-60RS, Seahawk helicopters for anti-submarine warfare. ASW, search and rescue, SAR, and cargo transport. The Ford also uses the C-2 Greyhound for cargo and personnel transport, although this is being gradually replaced by the CMV-22B Osprey, a tiltrotor aircraft that offers greater speed and range. The integration of the F-35C on the Ford is a landmark. The F-35C, with its stealth capability and advanced sensor systems, is the future of naval aviation. However, its operation requires perfect coordination with EMALS and AAG. EMALS is capable of launching the F-35C with greater precision and less structural stress, maximizing the aircraft's lifespan. The ability to operate the F-35C with a full combat load, something the Nimitz's steam catapults could not consistently achieve, is a decisive tactical advantage. The Ford is the only platform that can unleash the F-35C's full combat potential. The Ford is a floating city for about 4,500 to 5,000 people. The logistics to sustain this population are impressive and have been optimized compared to the Nimitz-class. Food. The ship has multiple galleys and mess halls, capable of serving thousands of meals daily. The food handling system has been modernized to reduce manual labor and waste. Services. There is a mini supermarket, ship's store, laundries, and even a gym and recreation areas. The Ford also has a complete infirmary, with operating rooms, and intensive care, capable of handling complex medical emergencies. Maintenance. The Ford has dedicated engineering hangars for jet engine repair and maintenance, in addition to ammunition magazines strategically located in the bottom of the ship to minimize the risk of explosions. The weapons elevator system has been modernized to be faster and safer, using electromagnetic technology to move munitions from the magazine to the flight deck. If you are impressed with the power projection capability of the USS Ford and its strike group, show your support. Like this video and subscribe to the channel for more in-depth analysis of the military technology shaping the world. Your engagement is what allows us to continue bringing this high-quality content. An aircraft carrier never sails alone. The Ford is the center of a carrier strike group, CSG, which typically includes cruisers, a Ticonderoga-class cruiser, which leads the group, providing long-range air defense and surface attack capability. Destroyers. 4 Arleigh Burke-class. Destroyers predominantly used for anti-air warfare and defense against ballistic missiles. Submarines. Virginia-class nuclear attack submarines, SSNs, which protect the group against submarine and surface threats. The CSG is a cohesive combat force, where each ship contributes to defense and attack. The Ford acts as the main command and control center, projecting air and naval power thousands of kilometers away. The communication and data fusion capability between the CSG ships is what makes American strike power so lethal, creating a network of sensors and shooters that is difficult to penetrate. Despite all the technology, the greatest competitive advantage of the U.S. is practical experience. The U.S. Navy has operated aircraft carriers for more than 80 years in countless combat scenarios. The coordination of hundreds of movements on the flight deck, the maintenance of complex systems in hostile environments, and the ability to quickly recover from failures are skills that take decades to master. This combat-tested operational readiness is what makes the USS Ford an unparalleled force. The Ford's crew, although smaller than the Nimitz's due to automation, is highly trained and specialized, with a greater focus on digital systems and predictive maintenance. The Ford's power generation capacity, driven by the A-1B reactors, is what prepares it for the future. This power reserve is essential for feeding high-demand systems that are yet to come, such as directed energy weapons, lasers, and electromagnetic cannons, railguns. The Ford is not just an aircraft carrier for manned fighters, but a test and command platform for the next generation of naval warfare, ensuring its strategic relevance for decades. The integration of combat drones, such as the MQ-25 Stingray, for aerial refueling and future attack UAVs, is the next step in the evolution of the Ford's air wing, leveraging the precision of EMALs. The ability to operate with less crew and greater logistical efficiency also points to a future of more sustainable and long-range naval operations. The Ford's nuclear propulsion is not just about speed, it is about operational sustainability. The ship can operate for long periods without the need for refueling, which simplifies logistics and allows the CSG to focus on the mission. In a prolonged combat scenario, the ability to maintain speed and autonomy is a decisive factor. The Ford's automation and optimized design also contribute to sustainability, reducing the need for maintenance and the size of the crew. The USS Gerald R. Ford represents the United States' unwavering commitment to global power projection. In a world where geopolitical tensions are rising, especially in the Indo-Pacific, the presence of a Ford-class carrier sends a clear message of deterrence. Its ability to operate anywhere in the world without relying on land bases for refueling makes it the most flexible and potent instrument of foreign policy. The capacity to generate air sorties at high speed and with greater frequency means that the Ford can respond to crises with overwhelming force, ensuring air and naval superiority in any theater of operations. The continuous modernization of its air wing, with the integration of stealth fighters and drones, ensures that the Ford will remain at the forefront of naval warfare for more than 50 years. The tactical heart of the USS Ford is its Combat Operations Center, COC. Unlike older carriers, the Ford's COC is highly digitized and integrated. It receives and processes data from all the ships and the strike group's sensors, creating a real-time battle image. The advanced network architecture allows command officers to make decisions at an unprecedented speed, a crucial factor in modern warfare, where the speed of information is the key to victory. The COC is where the fusion of data from radar, sonar, electronic warfare, and signals intelligence is transformed into coordinated tactical actions, ensuring that the Ford and its CSG are always one step ahead of any threat. One of the less visible but most crucial advances of the Ford is its emphasis on predictive maintenance. Sensors throughout the ship continuously monitor the performance of critical systems, from the reactors to the catapults. This allows the crew to identify and resolve problems before they cause operational failures, increasing the ship's availability. Onboard logistics have also been optimized. The Ford has a more efficient and automated ammunition handling system, which reduces the time needed to rearm aircraft, directly contributing to the higher sortie rate. This logistical efficiency is a power retention factor on the battlefield. The reduction of the crew by 600 people compared to the Nimitz-class does not mean less power, but a shift in focus. Automation on the Ford frees sailors from repetitive and physically demanding tasks, allowing them to concentrate on higher-value functions, such as data analysis and tactical decision-making. The Ford is designed to be an information warfare ship, where decision superiority is as important as air superiority. The integration of artificial intelligence and machine learning systems in the future is the next step to maximize this advantage. The ship's name honors the 38th President of the United States, Gerald R. Ford, a World War II veteran who served aboard the aircraft carrier USS Monterey. The Ford is not just a ship, it is the continuation of a legacy of naval power that dates back decades. The Ford class is the future of American naval aviation, with plans to build at least 10 ships. Each of them will be a test platform for the next generation of technologies, ensuring that the U.S. Navy maintains its supremacy in the world's oceans. The deployment of the USS Gerald R. Ford in the Indo-Pacific is a significant strategic move. The region, marked by growing tensions, requires a robust and technologically superior naval presence. The Ford, with its ability to generate more sorties and operate with greater autonomy, is the U.S. response to the rapid growth of the Chinese Navy. Its capacity to operate the F-35C, a fifth-generation stealth fighter, ensures air superiority in contested environments, a crucial factor in any potential conflict over Taiwan or in the South China Sea. The Ford is, therefore, the centerpiece of the American deterrence strategy in the world's most volatile region. Despite being a war machine, the crew's well-being is vital for operational effectiveness. The Ford was designed with significant improvements in quality of life. In addition to more comfortable accommodations, the ship has a more efficient air conditioning system, better air filtration, and less noise and vibration due to electric propulsion. These improvements, although seemingly small, have a direct impact on crew morale and readiness. A rested and high-morale crew is more effective in combat, and the Ford was built with this philosophy in mind, recognizing that the human factor is the ultimate differentiator. The Ford's power generation capacity is what truly sets it apart for the future. The electric power reserve is the prerequisite for the integration of next-generation armaments, such as electromagnetic cannons, railguns, and high-energy laser weapons, HEL. Although these systems are still under development and testing, the Ford is the only aircraft carrier capable of supplying them with the necessary energy for continuous operation. This ensures that the Ford will not be obsolete in the near future, but rather the launch platform for the next revolution in naval armament. Although the initial cost of $13 billion is high, the Ford is designed to be more economical in the long term. The reduction of the crew by 600 people saves billions in salaries and benefits over the ship's lifespan. Furthermore, the need for less maintenance and nuclear refueling every 20 years instead of 13 significantly reduces operational costs. The Ford is an investment in the future, where efficiency and the ability to operate for long periods without external logistical support translate into a strategic and economic advantage. The USS Gerald R. Ford is not just a warship, it is a living test platform. The U.S. Navy plans to use the Ford and its sister ships to continuously test and integrate new technologies, from more advanced electronic warfare systems to new types of unmanned aircraft. This capacity for adaptation and evolution is what ensures the longevity and relevance of the Ford class, maintaining American technological superiority in the oceans for more than half a century. The Ford is the first aircraft carrier designed from the outset to operate with a mixed air wing, including a growing number of unmanned systems. The integration of the MQ-25 Stingray, refueling drone, is just the beginning. The capacity of EMALS to launch lighter UAVs and AAG to recover them with precision is fundamental. The future of the Ford's air wing will include the F/A-XX, a sixth-generation fighter, and a variety of combat and reconnaissance drones. The Ford will act as the command and control center for these drone fleets, extending its attack and reconnaissance range far beyond the horizon. This synergy between manned and unmanned aircraft is the key to the carrier's survival and effectiveness in the next era of naval warfare. The Ford incorporates significant improvements in its combat survivability. The design of the smaller and more setback island, for example, reduces the radar signature and frees up deck space for aircraft maneuvers. The point defense systems are highly automated and redundant. Furthermore, the Ford has a more advanced damage management system with greater automation in flood and fire control. The armor and internal compartmentalization have been improved to withstand attacks from new-generation anti-ship missiles. The ability to generate and distribute electrical power flexibly also means that the ship can isolate damage in one area without compromising essential propulsion or combat systems. The presence of the USS Gerald R. Ford in any theater of operations is in itself an act of deterrence. Its ability to project air power on a massive scale, combined with the stealth of the F-35C and the capacity to integrate future energy weapons, sends a clear message to any adversary. The Ford is not just a weapon of war, but an instrument of foreign policy that shapes global behavior. Its deployment in the Indo-Pacific, in particular, is a sign of the U.S. commitment to maintaining stability and freedom of navigation in international waters. The USS Gerald R. Ford is the pinnacle of American naval engineering. What is your opinion? Does nuclear propulsion and American experience guarantee superiority, or can China quickly catch up? Leave your comment and activate the bell so you don't miss our next analysis on the naval arms race.